Testing 1, 2, 3. Okay, so this is assignment 1 of the SQL database, SQL course. So initially, what I have is I have a file which creates the table from a database. The database that I'm using is AdventureWorks. I have included a link of where you can find it. And I believe you already have this on your computer. So initially what we'll do is we run the script, and what it does is it creates 3 tables. It creates a base table, it creates a cluster table, and a non-clustered table. So the base table basically doesn't have an index, whereas the clustered table has an index, a clustered index on the first name column, and the non-clustered similarly has a non-clustered index on the first name column. So when you run the script, it generates the following result set. So the columns that we have are first name, last name, and country region code. Now this country region code would be used to do a join with the country names. The unique identifier is created using the new ID method, and its data type is unique identifier. So all 3 of them have 4.7 million rows each. So 4.7 million rows each. Now, if you look at the first one, it does not have an index on it, and it just randomly generates the names. The second one has a clustered index, so it's sorted by first name. So Zoe is like the last first name. And the non-clustered index also doesn't sort it while it's storing. So this is what the result set looks like. Now I've structured it for the video. I've structured it a little bit different. So I have a bunch of files which would do the individual test, just so that I can show the results properly. But the final submission would have just 2 files, one to create it and one to run all of the remaining tests. So we're going to start with, so I'm just going to run all of these tests. So some of them might take a little bit longer, but while I explain the rest, they should be done. So these are the files. So we'll look at the where test first. So now in this one, what we're doing is the SQL query that we're running. Basically, we will run it on all 3 tables. So the base table, clustered and non-clustered table. We're going to look up where the first name is Zoe and the last name is between A and S. So the last name would be like starting from B all the way down to R. Now, when we run the execution plan, okay, so with the execution plan running, what we see is that when we do when we run the SQL statement, okay, and also this is ordered by first name, last name, and country code. What this does is that it ensures that our result sets are the same, besides the GUID, of course. Now, all of these where statement roughly generate 5,000 rows. So the fastest one was the non-clustered version. Then the clustered version was the fastest, non-clustered after that, and then the slowest one was if we didn't have any index on it at all. Now I've put this tabulation in this nice sheet, and we see that the clustered is the fastest, non-clustered after that, and then no index. So this is our where state. Now, while this is being completed, we will look at the join where. So with the join where, what we're doing is we're doing an inner join on the country region code. And the number of countries, I think there's 170 something there. So we're initially doing an inner join, and then we're basically looking for country where country is Canada. So, and we're also ordering it. So in this situation, what ends up happening is that we see that clustered is, we see that the clustered is the slowest. The non-clustered and the no index version roughly gives us the same execution time. So you can see the 32%, 35% and 32%, and it's relative to like the file, the queries that are run in the file. So this is, so when we're doing a join and when we have a where clause, it might be better to opt for the non-clustered or not put an index in there at all. Now, now we're going to look at the join clause. So when we did the join, these would render the 4.7 million rows. So the last name would be Zoe Watson from Zimbabwe. And in terms of the time analysis, we see that the clustered takes more time than the rest of them, and the non-clustered and the no index version are usually better in this situation. Now, when we do the sorting operation, now in this one, I'm just sorting it by first name. And what I'm doing is I'm going ascending order and descending order for each of the tables. So there will be 6 tests altogether, and then we'll do the comparison for them. So first name ascending order, first name descending order in the base table. And then like this would give us 6 timings. And what they look like is the following, that we see that the clustered index is always the clustered index is always more efficient. So the clustered index gives us the best time. The no index version gave us the second best time. And the non-clustered version always gave us the worst time. But they're almost very similar, so these two are kind of in the same bracket. Yeah, so this is an explanation of this is setting up indexes in the indexes time analysis. Now, given that the number of rows for each of the individual tests are the same, so the UI with the UI and without the UI versions, both of them gave the same amount of time because the UI rendering time was constant for all of them. So this was assignment 1 for SQL indexes. Uh, Thank you.